Okay.
You
guys may have
Okay,
a little...
everyone.
Well, I'm also my presentation.
So I would ask that you mute your microphone unless you're actively speaking or asking a question. So thanks for joining us today. This is a low-key workshop that we called after several members of the DRCW asked about how they were going to hit the new or detect total chlorine residual down to the new or below the new standard that was appearing in permits, which is 0.038, down from 0.05 in the previous permit. This change has been driven by technological changes in detection for total residual chlorine. And what we did today was I knew that there were a few members that had looked at this in some detail, and we're working on equipment and processes to allow them to do that. So we've invited today staff from the Metropolitan Water Reclamation District and from Downers Grove Sanitary District, and they're going to talk about how they approach this problem, what equipment they purchased or are using, and what their SOPs are around that. So a couple of notes. We are going to try to make sure that you are muted. We're talking. We left this in this more open style so people could ask questions. But please, if you're not asking a question or if you're not presenting, please make sure that you are muted. We are submitting this workshop to IEPA for CEUs. As our next work group meeting, we'll also have that. As in the past, we've offered PDHs, but working with IEPA to get recognized for wastewater certifications as well. And with that, I am going to hand over to our first two speakers, and let me introduce them. So our first speakers are Lucille Wisha, and she is principal engineer at MWRD Egan plant. She's in charge of treatment for both liquids and solid operations. And as prior to this position, Lucille worked at various capacities at MWRD, and is most of which were in operations, and she has over 25 years of experience. Also joining her is John Cargbo. He has 18 years experience at the district, and for the past 4 years, he's held the position of lead operator at the Egan plant. And welcome to...
I didn't get that at all. Like, my email was just from Stephen, but I'm not getting that.
Good morning, everybody. Can you hear me? Can everyone hear me?
We can.
Okay. All right. Good morning. Thanks for giving me the opportunity to talk about our experience with chlorine instruments at the Egan water reclamation plant. So I've been here since May 2017. When I first started, we had two chlorine instruments, two titrators that were in use. One of them was really outdated. It was an old instrument that wasn't supported anymore. The instrument came with a lot of warnings, things like don't touch this, don't move this. But it was what we used at that time. We had a second instrument that we were just trying to, at that time that we were trying to break in. They were still working on setting it up, but it was available and we were trying it. So one day, the regular instrument we were using, I mean, it just stopped working. We needed an alternative, so we started using the second instrument that was just set up. That worked for a while, and then maybe a month or two, that stopped working as well. So we needed another instrument, yet another instrument. At the same time, we were using the spec, the one you see in the picture. We didn't use it for chlorine, but we used it for like nitrates analysis, nitrites, cyanide, alkalinity, things like that. We didn't use it for chlorine at the time. So we figured hello?
Hey.
Go ahead.
I know you do, and I'll be there tomorrow. Sorry.
All right. So we needed another instrument And we had the spec, which we had already been using for, like I said, for like nitrate, nitrite analysis. Staff were pretty familiar with it. It's a really nice instrument, easy to use. It's cost effective. It only needs one reagent typically to use. So we decided to revert to using the spec for chlorine analysis. We did that for a while, maybe a month, maybe 2 months. But one day, one of our operators approached me and he had a concern. The concern was when we use the digital titrators, we always got a 0. It was always 0. When we use the hack spec, you always got a number. I mean, it was a number that was less than our limit, which at that time was 0.05, but we always got a number, 0.01, 0.02. I think the highest I ever saw was 0.03. So that raised some concern for us. Because what happens, for instance, what happens if you ever hit 0.05? Is it a violation? So we, as a team, we were uncomfortable with this, and so I mean, I would say that's one of the negatives of this instrument. That's why I say less precision. Also, this instrument has a light source. After a while, it does deteriorate. There are some issues. We do have a service contract. The instrument has to be serviced periodically. Next slide.
1 second.
Okay, so like I said, when we started, we had 2 instruments. This was the second, an older version of this one was the second instrument that we had. Because of this, I don't know if you want to say noise from the spec that was giving us all of these readings that we were uncomfortable with, we went back to using this instrument. It turns out that the problem was with this instrument was the probe. The probe needed to be replaced. So we replaced it and started using this, and that's the instrument that we've been using ever since. Now, an advantage for us was that our operators were already familiar with this instrument. This instrument goes to 4 decimal places. So we didn't have the same issue you had with the spec. We didn't have that in terms of the precision. Now, if you compare them instrument to instrument, the cost of the units are probably identical. But just from looking at this picture, you could see this has more components. So in the long run, I think this is going to be more expensive. You could also see, I mean, it uses more reagents. One of the nice things about the spec, for instance, for some of our other analyses, if you look at nitrate, if you use the reagent that's provided by HAC, that you could get from HAC, if you use that reagent, all it takes is put on the sample in that vial, put it in the spec, and it'll scan the barcode on it, choose the program it needs, and reads for you, probably all in less than a minute. Not so for the titrator. It could take a while for you to get your results. It also probably requires more maintenance. The probe at least has to be conditioned every now and then. So I've talked more about the instrumentation. Of course, it takes more than just instrumentation to get this going. So Lucille will pick up from here and talk about the rest of our experience. Thank you.
Thank you, everybody. Thank you, John. Thank you for the opportunity to present our findings or our challenges that we've had. Could you please move to the next slide? So John did mention that we had to buy a new instrument because the other one, there was too many problems with it at the age of the instrument. We got a newer version of the same instrument. So we had to give time because I don't know how long it takes for you guys, but the districts, there are some protocols. So we had to give time to allow us to acquire the equipment and the labware that we need to be able to set it up for the last chlorine season. So this past chlorine season, we started using the new instruments that were acquired. What was the key thing about why we chose that instrument is because of where we could dial it down to the detection limit, and I'll go into that. Instrument setup is a key component. It depending on how experienced your lab personnel are, it determines how well, it determines how easy it would be for you to transition, because that experience played a part in allowing our lab personnel or our TPO to troubleshoot the problems that we're having with the instrument. Part of it being that we didn't know we needed to do some conditioning. And eventually when we reach out to the manufacturer, we're able to go past that to start getting correct readings. The digital, one of the key things that was, or a couple of key things. One is the actual pipette that we use, and then also the labware that is associated, other labware associated with it. Now we went through a different types of titrate pipettes, and we settled for these two. We have shown that the two that we found to be helpful. Now the one on the left is a digital titrator. That titrator is what we're using right now. What it does is you dial in the number here, and with that dial-in number, it goes from 0 to 10, both of them. We dial in any volume you want to pump, and then just press the button on the top. There is a limit, and if you press it carefully, it will deliver that volume. The one on the right is automatic. You put in the volume you want, and you press a button, it take that volume and dispense that volume for you. Now, the key thing that we found to determine that these are the most useful is that we took a known volume of water. We all know what water weighs, and we weighed it using both pipettes, and it was able to deliver the same weight. So that's kind of a quick check for you to know if the titrator you're using, you can have different people do it, determine if you're going to repeat the results most of the time, because this is crucial, because if you don't have the volume you need, you're going to have, your QA is going to be out of range. So then the glassware, depending on what you're looking for, usually we use a conical flask for the mixing, dilution. And we've used, depending on what we've done anywhere from using a 1,000 to 2,000 milliliter conical flask with reverse osmosis water. So QA standard, why we put it here is because there are so many standards out there, but we found out that even though they had 100, 50, and the rest, we actually went down much lower than that. But we're fortunate that our lab, we have accredited lab here that was able to make the standard for us. Now, the lower the concentration of the standard, the more unstable it would be. And that's what the experience of the lab, the TPO comes in, because when we changed the standard, we ended up with a 10 ppm, and I'll go through some of that, how we decided on that. But when you change this, when we changed the standard to 10 ppm, we realized that after about a month or so, the results were no longer consistent with what we were getting before. So the operator brought that to our attention, and we're able to go back to the lab and get a new standard, and then it came back up. So stability of the standard was shorter for the less concentrated stock solution. So you have to pay attention to that, know when to reorder your stock solution to be sure that you're going to be able to keep up with the right QA numbers. Your numbers are repeatable, and the recovery is good. The QA chart, for that, if you're just starting, the first time you're gonna have to have maybe a month worth of readings, at least 20 points to be able to even have any QA chart of any sort. And I'm sure you guys know all that's involved with a QA chart. I didn't really pull one here. I'm assuming everybody knows about QA charts. And that's it for here. Can I have the next slide, please? Okay, so the QA adjustments, dilution. This was one of our biggest challenge in the sense that we first started with 1 part, 1 ppm, 1 milligram per liter as our QA. This was a long time ago. And then when we got this permit, we went down to 0.5, but it was still high in the sense that you couldn't use the advantage of the instrument's lower detection limit. So when we went down to 0.5, I believe we're still using 100. So we're taking like 1 ppm and diluting to 200, 2000, 10 ppm and diluting to 2000. But then that was still high. And we decided we were going to go lower. So when we're going lower, if you're administering much lower ppm, much lower volume, it makes it harder for you to get the accurate reading. So we wanted to go to something where we could still pipette much more volume, but then do the dilution to get what we're wanting for. So we started going down on the standard, and eventually we settled for 10 ppm, which I said the lab makes for us. So with that 10 ppm, we've been able to consistently, we're able to go to 0.05. With a 10 ppm sample, if we take 1 mil of that in 1,000, it's 0.005. We take 10 mil of that in 1,000, that gives us the 0.05, which matches what we have right now. But we're still in the process of dialing it down because the instrument we've chosen is capable of going down to 0.0005, 4 places of decimal. So we're dialing down that number because we want to get another stock solution that is able to bring us down with the dilution. Either we stay with the 1,000 or we stay with 2,000, but to get to a lower dilution. So after this point, we're doing it in stages because we want to be able to handle the challenges that we get with it, to not overwhelm ourselves. So the next step we're going to go to from 0.05, we're going to go to either half of that or we do 0.02. And then from there, we'll go down to 0.005. So it's a gradual process for us. We still have a year to get to that number before the limit comes. And why are we going to the lower detection limit? We're doing that because if we're able to hit the low detection limit, we can then safely claim that any number we get that is 0, we can say is less than 0.005, which makes it a safer place for us to be than where we are right now. So the pipetting techniques, we kind of talked about it. The only other thing I want to add is you have to have different people try the different pipettes to see where you get consistent results for you to know what to settle with. There are so many of them out there, but some of them are prone to errors, but the 2 we showed you are the ones most crucial for us. Then operator experience. When you're setting up, it's good to use your most capable or most experienced operators because they're able to tell when there is a difference already in that. And you're going to also use them when you're retraining the other operators. and or the new operators that you have. Now, we use consistently the same shift to do all permit related things so that they're used to it and they do it all the time. But then you have times when you have other people who are not part of that crew that would have to work that shift, either overtime or something. Then you also have to keep up with their skills, in training them, making sure that once in a while you have them do something to be sure that when they have to do it, they will know what to do. So that's been our experience so far. I don't know if I missed anything, John.
No, that's it.
Okay, so that's all what we have. And then when we eventually dial into get our 0.005, if anybody's interested, we'll let them know what it is. Thank you.
Stephen, do you want to introduce Rhys or? Okay.
I can just go if you want.
So I don't know where Stephen has gone off to, but our next speaker is Rhys Perry.
Oh, I apologize. I was
There you
talking
go.
and I was muted. Yeah, I
That's
apologize.
fine.
Yeah, yeah, I can understand. It's like, well, I just said I was going to introduce him, Dina.
I was gonna try. I mean, I could read his name
Yeah.
from the slide.
Right. Yeah. Sorry. I apologize about that. So yeah, our next. Thanks very much, John and Lucille, for that. And we're going to introduce our next speaker, and he'll talk, and then we'll do question and answer. So our next speaker is Rhys Perry. He is a graduate of Monmouth College with a degree in biology. Total of 21 years lab experience, including 18 in wastewater, and a further 6.5 at a beef processing facility that had on-site wastewater treatment. He has been with Downers Grove Sanitary District over the last 11 years. So with that, welcome, Rhys, and let's run through your slides.
Sounds good. Thanks for having me. Just to start out, we haven't gotten in depth with a lot of the quality assurance things that the previous speakers talked about. So we're still kind of trial and error some of that, and playing with our standards that we currently are purchasing through FANOVA or ERA. Either one, they're the same to us. So the first slide for how we kind of went about this from the very beginning is the initial research for me was I found this titration method, the forward and back titration method. And I started thinking about it and getting some quotes and thinking about maintenance, buying consumables, having somebody in the unit.
Oh, for cleaning over there. And then dusting.
What the eventual replacement cost would be down the road. So I started kind of thinking about those numbers in my head a little bit. And speaking with my supervisor, we thought it was probably best to reach out to Illinois EPA just to kind of get an idea of maybe what their thoughts were, what they would recommend for us, or which path if we were going to go down one of these. They really didn't give us anything like, hey, you got to do this method or any of that. They just said, as long as the method chosen, and I put this in quotes because this was just an email from Michelle Rousey. She said, the key is to ensure the method or instrument is able to reach or go even lower than the reportable concentration levels required for compliance. And so after I got that information, we thought, I guess it was more of just me just kind of just sitting on it, and we didn't really make a move for a few months. And then we got our a draft of our permit, and then that kind of set the ball in motion a little bit more for us. And I decided to maybe look at other options and see if there were any other options beside the titration method. And we can't remember how we got to Hawk method 10014. I think it's between the lab analysts that we have working here, the two that we have here, and then myself. I think we just kind of started looking for alternatives, and we found this. And speaking with a Hawk rep, we decided that it was worthwhile to look at it because we had a Hawk spec already, and it would be fairly familiar for our analysts and for myself to step in and analyze the ultra low, which is similar to a degree to the Hawk 8167 method, which is the DPD method that probably everybody uses right now. Next slide. So we did a little more research on the Hawk 10014 method, and we realized that it was acceptable for US EPA. Some of the steps when you're looking through the method, if you guys want to Google it, it's pretty easy to pull up through the Hawk literature, but there are extra steps, and there's some steps that you want to make sure that you're I don't want to say paying more attention to, but you want to make sure you're doing the steps as it says and not getting sloppy with your technique. Some of the equipment that is different with that is like the pour through cell, the Oriflow filter apparatus, making sure that there's a new fresh filter each time, mixing cylinders, which we never really kind of used before, and then just prepping of that glassware in between each analysis. With this method, it's going to bring in new reagents that we have to use. The glassware was a little bit different, and then just stocking some different things that we didn't before. So there is some cost with that versus the other method. We did find that when we first got the equipment, when we first started using it, that it would have been really nice if we would have purchased another Oriflow filter apparatus and extra glassware. Because when it came to duplicate analysis and trying to meet the 15-minute hold time, we were running up against that every time. Just with the distance of where the sample gets pulled, operator would typically drive that up to us, and it's a couple-minute drive away from where our lab's at. So by the time we get the sample, we were looking at under 10 minutes of hold time remaining to analyze sample, duplicate, and get all the analysis completed. So we think it was ideal to purchase that extra equipment just to make the stress out of that situation, just take that away right off the top. Next slide. So in this picture, you can see our DR3900. We did it, and in the background, you can see the DR5000. It does have the capability of running this analysis. That unit in the background that you see, the DR5000, is about, I'd say it's almost 12 to 15 years old. It was here before I started with the district. So going into this, I knew we were going to be purchasing a new piece of equipment. In our budget, I didn't want to have to purchase two pieces of equipment within 2 budget years. So that's kind of unique to our situation, but it might apply to somebody else. So I thought I'll upgrade our current spec to the 3900, and then we'll have access to all the bells and whistles on that piece of equipment. We won't have to purchase another spec for hopefully 15 or 20 years. And we won't have a second piece of equipment that we weren't using before and maintaining on our benchtop. Yeah, we could have purchased a titrator, and we could have, brought it up to speed and set everything up, become very familiar with it and used it. But I think long-term for us, we were thinking more of just cost-effective right now and meeting the limit requirements in the new permit. And we feel that with the 200 to 500 micrograms per liter range this method provides, that we're going to be able to meet that consistently. I would say that if I was going to recommend anything, is right out of the gate, purchase the extra glassware and the Oriflow filters, and they'll make your life a little bit easier. So that's kind of all I had. Like I said, we didn't get into any of the quality assurance as much yet. We're still trying to work through some of those issues and what we can really kind of comfortably detect down to. But we've been getting results in duplicate analysis that are 0.002 and 003 pretty consistently so far.
Okay. Thanks, Rhys. And want to be clear, both these organizations are currently working through this process. The permit, as is coming out, we argued for extra time in there to allow members of the at the lab to get used to the process, used to the equipment, and check that they, as Lucille was pointing out, that you can produce consistent results, as this is being reported as a daily max. So it's not, there's no averaging, etc. in here that gives you that added layer of protection. So with that, I'm opening it up to questions. If you have a question, please, you can put it in the chat, and I will verbalize it, or you can unmute yourself and ask the question, and leave it open for discussion. Just check that if you're careful when you're unmuting, that we're not talking over each other. But we're a reasonably large group for this, but we should still be able to manage it with a little bit of discipline. So with that, I'll invite people to ask questions.
Rhys, this is Adam Gronsky with the Water Rec. So that 3900 can read to the 1000th decimal point?
Yes, it can under the 10014 method. It does read decimal.
Yeah, I thought that was interesting because we didn't think to change the method to try that. But...
And then, so Rhys, on those methodologies, were there any other constraints on using that different method?
Not as when you're asking that question, what do you mean?
Well, I mean, in terms of I know you were pointing out there are some operational issues with the hold time, etc. And so, I mean, in practical, the practical implementation of it, I guess, is what I'm asking. Were there any?
Yeah, so within the method itself, I mean, there are timed portions of that method where you have to wait like 3 minutes when certain reagents are added before you can read. So if you get the sample and you're under 10 minutes and you have this 3-minute timer that's staring you in the face, if you only have one piece of equipment like the Oriflow filter or the mixing chamber, the mixing cylinder, then you got to wait. You have to wait to start your duplicate analysis until after you've completed your first one. So you're going to be behind the 8 ball a little bit as far as time goes. So that's why we bought double the amount of equipment.
Yeah.
So we could be doing one analysis while we're prepping the second one.
Okay. Thanks. Okay. Other questions? Just checking here on the.
Hey, Stephen, it's Ben over at Bolingbrook. I do have a question. Is that the only way to get a reading in the thousands place? Is there any other piece of equipment anybody knows out there that will read to that decimal place?
So Benjamin, yeah, in terms of that question, we do have 2 vendors that are going to be talking after we wrap up this question and answer period. So the HACK, who obviously is one of the instruments that both organizations here are using, and then also YSI, who have an instrument capable of doing it. And so they'll be running through, those are 2 options. We did have a 3rd vendor, but they wanted a bit more data from their own testing procedures before sort of talking to publicly about it. So they stepped back from presenting today. But these were 2 instruments that we had pointed out that could do this. But that's my answer. I'll turn it over to MWRD and Downers Grove Sanitary District to weigh in.
When we did the research with Downers Grove Sanitary District, we found that it was forward and back titration. You could do either one. And then those titrators were available through HACK. And I believe, well, as Stephen mentioned, YSI. And I'm not sure I should even mention the 3rd vendor, because if they're but I don't know. We looked into Metrum was another vendor that we looked into. If they had a piece of equipment, I can't remember if they did or not. I think they have titrators, so that's why I looked with them. And then we kind of came back to the spec just because of our ease of use, and we've been using a spec for other analysis and other analytes. So
yeah, so my information is they do have an instrument that can do it, but the person who was put forward for speaking in this, they didn't feel he had enough information on that particular instrument to speak. So I'm not transferring that to the whole organization. I got the impression it was he felt he needed more, some more familiarity with it before speaking. So I didn't push push them for it.
Okay, this is
Question?
Lucille.
Sorry, Lucille, please.
Yes. Oh, so we use the HAP titrator, and we've used that for the past, I don't know, most of the plants have used it for over a decade. We just got a newer form of that, and that's dials down to four places. And we found it very reliable and easy to repeat the results. So it uses, yes, it uses a little bit more chemical, but once you get used to it, there isn't a lot that could deviate from that, unless if your dilution is off.
Okay, other questions? And obviously in terms of cost, et cetera, and upkeep, then I think that, I don't know that we've enough experience to speak in that, but the vendors can probably speak to their individual instruments. Okay, I'll give this another 60 seconds to realize, you've got to unmute and everything to ask a question. So I had one. I was just noting, and I know this is something that Lucille had really belabored, and I think it's a good point, was checking that the testing mechanism could stand up to different operators using it, and perhaps slight variations in the process and still put out consistent results, so we know that we were accurately measuring what we had in there, and that that your SOP was robust enough to stand up to a change in personnel. Okay, so I will, I have all the speakers' information, so that if folks did have questions or wanted to get in contact with one of the speakers, you just shoot me an email. Everyone has my email. I will see that they get the information, or if you had questions, send them to me, and I will get them to our speakers. So if we are okay to move on, Steve, I think you had some slides to share. Steve, are you with us? Oh, I see. He's connecting. So, okay, give me a moment. Okay, Steve, can you hear us?
I can. Can you hear me?
We can hear you.
All right, great. But
there is a bit of an echo, Steve. Are you?
Let me turn that off. Can you hear me all right?
Yep.
Can, yes.
Hello?
Well, is your phone still on?
Hello?
That's much better. Steve, you also had some slides? I'm
not sure what's happening.
Yeah, hold on. Let's give him a moment to.
I can't hear you.
He can't hear us. That's like an issue, I think, with his audio. I don't think I can do anything about that.
Yeah, that's certainly limited options for us. Steve, just confirming you cannot hear us. Obviously, it's kind of a good question for an Irishman to ask. I tell you what, maybe what we'll do is we'll jump on to Terry, and we'll see if we give Steve a little bit of time to work on perhaps reconnecting. So Terry, we're going to share that PDF that you sent through to us.
That's okay. I would actually like to address a couple of the things that everybody was talking about
Sure.
with the procedures. Cleanliness is next to godliness when we're doing lab work and measuring that level of chlorine. So the cleaning of the glassware is very critical. That goes for every part of the process. And that's one of the biggest things I see is technique. If you've got an SOP and they know how to do what you're telling them to do, your results will be very good. The ultra low chlorine has been used for many years in lots of other states that have actually lower limits than Illinois, and down as 0.02. So it does work and it is acceptable and does a good job. As far as the titrations, the forward titrations, the only one that I think we can get down into that very low level with. It's one of those things where the back titration has too many potentials for problems and does not give us the detection limit we want. We've been using a lot of these methods with like the amperometric method with power plants. They are required to use it in many cases, and that's in their permit. So we know that it will get down into the extremely low level and do it accurately. Standards are always going to be a critical problem when you're making a chlorine standard or a chlorine equivalent standard. And you can make chlorine standards from ampules of chlorine solution and be very precise with these low-level standards. I understand you're probably using a permanganate equivalent standard at 10 milligrams per liter to make these other standards. Is that correct? I guess it'd be Lucille.
I'm sorry, could you say that again?
Are we using a chlorine equivalent standard to make the standards in your evaluation of the instrument?
I believe so. Our lab does it for us. I believe so.
Okay, normally permanganate has been the chlorine equivalent standard for years. But you can make a chlorine standard with chlorine ampules and get very good numbers. However, those are only good for a day. They are not good for extended periods of time. But it is a good way to double check and make sure the other standards are working as you should.
I'll find out from the lab for sure. Okay.
Well, like I said, for many, many years, chlorine equivalent standards have been permanganate, and they can have 1,000 milligram per liter stock solution that's very stable, and then make up other stock solutions for you. So that's the normal thing. Chlorine is a very difficult thing to have a real standard. Most of what I've seen with lower limits is most systems are doing very well at chlorinating and probably over feeding their dechlorinating agent. So it ends up being, it takes out dissolved oxygen as you go into your stream, and that could be a problem in some cases. So feeding the right amount of dechlorination, oxide or whatever you're feeding is extremely critical in not depleting your oxygen as it goes into the receiving streams. That will be something that I don't know if you have limits on that. There are places where the limit on dissolved oxygen going into the receiving stream is as high as 6. It can't be below 6 milligrams per liter. So overfeeding the sulfur dioxide can drive that DO down considerably. So critical, being very careful with your dechlorination is extremely critical to maintaining that dissolved oxygen. So we don't want to overdo. If a little bit's good, a lot's better, and it we want to put in just enough. Along those same lines, we have a new version of our CL17 online chlorine analyzer that can help control such things as chlorination, dechlorination, and give you the ability to have much better control. And we have the ultra low range version of that will allow us to get down into the part per billion, single digit part per billion level accurately. So it's something that will help you with that so that in low flow times, you're not overfeeding, or you don't have enough chlorine, you're not overfeeding, those type of things. And flow pacing is one of the things most people do with their bisulfite or sulfur dioxide. And so doing that with a chlorine analyzer as a trim, so to speak, allows you to prevent the overfeeding. So that's something that we can talk about. I'll be glad to talk to anybody about the technology and what we've done. And I'm kind of spilling the beans a little bit. The new ultra low CL17 won't be introduced till after the first of the year, but I've been working on it for the last 2 years, so I am familiar with it. Anybody have any questions? I've got one other thing I want to bring up. Manganese correction. Are we required to do a manganese correction on our chlorine analysis in Illinois?
I didn't see it in the permit. That's Lucille, John, and Rhys, or anyone else. Is anyone familiar with that? I haven't seen it. No.
I didn't
think so.
that.
Okay, manganese correction is something that's required in many states where you actually are looking for manganese interference in your chlorine residual, so that 1 milligram per liter at the end of 20-minute contact time could be in jeopardy. So if you have a manganese correction of 0.1, then you're really at the end of the contact time, you only have 0.9 instead of 1. So that's something that we've seen systems get into problems because they weren't doing the manganese correction. They weren't adding enough chlorine to overcome that interference. And then they were being written up for not having enough chlorine at the end of their contact chamber. The flip side of that is that if I have a manganese interference there, I'm going to also have a manganese interference on the dechlorination. So theoretically, the same interference would apply. And manganese is a direct interference with chlorine residual, gives you a positive interference, as well as other operators, but normally those aren't something we run into at the end of a wastewater treatment plant. So that's just something to think about. Manganese correction is something that other states are doing, and it is there is a way to find out how to do it. It's in the interferences in the method, so you can actually check the manganese correction and see if that will keep you from getting in trouble on the front end of the process, and maybe a get out of jail free card on the back end. I figured I'd generate some questions on that.
Yes, yeah. So I'm going to open up for questions for Terry. And once again, I didn't get a chance because we had had a bit of a technical issue there, but we are talking to Terry Smith from Hack. So he is he's been with HAC since 1984. He's worked with every version of their chlorine analyzer and is currently involved in developing the new CL17 SEC and the soon to be released CL17 SC ultra low range analyzer. So okay, sorry for that belated introduction, Terry.
That's not a problem. I've been teaching people how to do chlorine testing since 1984. So it's not something new to me. My biggest deal is I want to be able to answer any questions anybody has on technique, anything you have on issues. Like I said, standards, all of these things I've done for many years. So it's very much second nature. And you can share my contact information with anybody that wants it.
Will do. I'll send it out. Okay, questions for Terry.
Terry, this is Rhys from Downers Grove.
Yes, sir.
What are you seeing people in the laboratories? If you have the CL17 online analyzer, what are you seeing in the lab for them to run the chlorine analysis, and which method are they using? Typically, do you see, and which ones do you see them having the most success with that?
For the majority of the tests, when they have a CL17 online, they're comparing it with the lab method that, like the 8167 that you talked about earlier. If we're doing the ultra low, then the method you're using with the DPD and the ultra pure reagents is what they use for that. And the comparisons are very favorable. You know, with any method, you have to develop confidence levels. You have standard deviations, and you have to figure out, okay, what I'm doing is I'm developing a chart to show, okay, where am I running? How many standard deviations am I off from where it should be? That type of thing when I'm running standards. It's basically a bell curve turned on the side. And you know that you want to be within one standard deviation if at all possible, but two is probably not a bad thing either. With chlorine residuals, the confidence level, 95% confidence level is great, but I'm finding that plus or minus 10% is not unreasonable when I'm running standards.
That is very good to know. Thank you.
So we will have another chance for question and answer with Terry, but I think we've got Steve's tech sorted out. Steve, are you with us?
I am.
Okay, we're getting a little bit of an echo, so maybe we're signed in twice now.
Yeah, so
Yeah,
try again, Steve.
How's that?
That's better.
That's it.
I muted your visual and just you're speaking through the phone because it seems like your audio is picking up sometimes through your computer.
Okay.
Yeah, right.
Yeah, yeah. There's always something. Okay.
Okay.
Let me introduce you, Steve.
Sure. Yep.
So Steve Wartendijk joined Xylem back in 2017 and has managed their central region process. He was with Black & Veatch, who has spoken with the DRSCW several times, as business development manager for their smart water team, and he's 31 years of experience in industrial product marketing and development, sales and management for municipal and industrial wastewater utilities, petrochemical and ultra pure water. For that, Steve was with the Air Force, where he was a captain and flight instructor on B-52s and an electronic warfare officer. Steve is a BS in chemistry from Oral Roberts University and MBA from Texas Christian University. Welcome, Steve, and I'll hand it over to you. Did you had a couple of slides you were going to pull up?
Yeah, I did, and I'll take care of that in a sec. I also, Terry and I worked together for many, many years, so it's good to hear you, Terry. So anyway, let's see. Can you see all right?
No. Now they're coming. There we go.
Okay. All right. So I'm going to be kind of quick with this, and I kind of really pared down the slides on this, but let's see if you can. All righty. So I know the focus has been a lot on the laboratory methods, and back in a previous life, I worked a lot with an ultra low range chlorine method, actually selling for Hawk, and the Arizona DEQ used it as their standard. It was actually in their permit to use that method. And interestingly, none of the plants could get down to the low ppb level. And a lot of it had to do with, we had to actually go in there and help them establish what their own limit of detection and limit of quantification was, based on a lot of the procedures that Rhys, you were doing, and earlier the guys doing the titrator stuff, very, very similar kind of things, but we were spiking an actual sample to come up with those LODs and LOQs using the standard methods procedure pretty much. And for the most part, I would say that most of the wastewater plants were getting into that 0.025 kind of ppm range. And what we ended up doing is we go back to the DEQ and say, look, here's the realistic in the world way that this works. Let's try it that way, right? And let's use that as the new permit based off of these findings. And they were open to that. But anyway, the point is that there's a lot of things that can affect the chlorine reading, both in the lab and then online. So basically, a lot of it, and these are some of the instruments I've worked on in the past. I worked for Capital Controls too for a bit of chlorination company. But basically, the pH, temperature, flow pressure, membrane permeability on amperometric probes. There's the time factor, which a lot of you have talked about. Large changes in chlorine can affect an instrument from reading to reading. And then there's all these interferences. A lot of the ones that Terry also just talked about. All of these things can affect your DPD reading. So, once, we've got a published limit of detection, and we've seen some real world experience too. And generally, I would say that it's highly dependent site to site to site where you're actually going to end up by the time you're done. This analyzer is an online analyzer, and it's basically like the CL17 in that it's using a DPD method. This kind of shows the reagent blocks. Did I just lose you? Can you hear me all right?
No, we can hear you. Okay.
Can you see?
Yes, we can. Everything's good.
Okay. All right, because my screen just went blank. But anyway, the point is that
now this
it went blank. It just did go blank.
Yeah. Okay. All right. I'm having an internet issue here where all of a sudden my internet is gone. So, but anyway, the 3017 is one that uses, and I'm just going to talk through it now since,
yes.
That was the rest of the people doing. So the 3017 is one that uses the DPD method. We've done a few things to the analyzer that helps mitigate some of those issues with reagent mixing and things like that. And it basically involves kind of a precise control of the amount of reagents that are coming into the to the flow cell. So we use a flow injection type of system, so that as the sample is coming through, the reagents are also mixing in the same kind of flow injection. And by the time it gets to the optics, it's gone through the color development, that kind of 2.5, 3 minutes color development time, and it's stable. And then it takes the read, and then it pushes the read out. And then when it's not reading, it is going through a cleaning cycle using the sample. So that sample is continuously running through the optics, in order to kind of flush out any residual reagents that might have been left behind. The instrument itself is, we've been building this for probably about 5 years now, mainly used in ballast water. It was called a total residual analyzer, and it just basically picked up our total residual oxidant, and it picked up all oxidants like any DPD does. Bromine, ozone, chlorine dioxide, permanganate, all of that stuff. These instruments will pick up and read. And it was kind of mounted onto the side of a hull of a ship as they used, they tested for chlorine in the ballast water. And we took that probably about a year and a half ago and took out the, all of the hardened stuff that you need for a ship hull and turned it into kind of a plant grade analyzer. And that's kind of the analyzer that you see now. Some of the other things we did is we made sure that it was compliant with the EPA method in terms of path length and wavelength of the analyzer. So all of that, makes it kind of a in compliance with that EPA Federal Register rule. We have used them in wastewater, drinking water, and aquaculture primarily. I would say the past 12 months, we have mostly sold these into wastewater plants. And we have found that, it's actually performed very, very well against any laboratory method. And we're seeing probably the limit of detection is about 0.03 to 0.02. I would say in drinking water, we're kind of hitting that 0.02 in some of the clean water applications, and in wastewater, it kind of ekes up to that 0.03 level. And again, I would say that the caveat is it kind of, really depends on the sample and what are the interferences that you're seeing, in the sample, because nitrites, certain metals, and then any kind of oxidant is going to react to DPD. And kind of in light with what Terry said, and from some of the things that we were looking at Capital Controls when it comes to chlorination and dechlorination, whatever your interferences are happening on the chlorination side are the same interferences happening on the dechlorination side. So you can still run the process pretty effectively with using these kind of online analyzers for both chlor and dechlor, and then check it against some of your precision lab work that you guys are doing now. And it sounds like, at least in the lab, the methods that you're doing, either the forward and back titration or that ultra low range chlorine, will get you to your goal. You just got to kind of be aware of some of those interferences that you're going to run into. And then in turn, you can kind of use that to validate any online analyzer you have to make sure that it's, working as advertised. So I think that probably is about 8 minutes on me. So if I'm going to pass it over now to you guys to have if there are any questions.
Okay, so we'll have questions for both Steve and Larry. Please, you can either put them into the chat or you can ask directly. I guess Kiko, I did have a couple. So and this is to both of you. So you both had introduced this this idea of interference. Terry had mentioned manganese, and then Steve had added another couple. Based on the kind of I realize every plant has its own somewhat of an experiment of one, but which of those interferences do you think plants should be most aware of if they were to prioritize and say these are the other things that we're going to look at to try to better control this chlorination, dechlorination process and detection?
From my perspective, and I'll allow Terry to jump in too here, but from my perspective, what I've seen is in the field, manganese is particularly rough because it's naturally occurring and you find it in the water source all the time. Now, in a wastewater plant, if for some reason the nutrient management is going awry, you could have high nitrites leaving, and that could have an impact on your DPD reading.
Okay.
I will concur that the manganese is the primary one I see a problem with. And it's a positive interference. The nitrite, on the other hand, is actually a negative interference. So you might less than what you think you have. So those are the two big ones.
And Terry, just to clarify for everybody, can you when you say positive and negative interference, just specify what it is that you mean by that?
Okay, a positive interference causes the reading to be higher than what it should be. Negative interference would cause the reading to be lower. So if I'm trying to get 1 at the end of my contact chamber and I have a manganese interference of 0.1, then I truly only have 0.9.
Oh, okay.
I'm too low with my chlorine residual, and I can be written up for that. Now, if it's on the other end, like I said, the manganese can be your get out of jail free card if you're right at the edge of your limits. As you can have that as a interference. It's in the method. It tells how to determine it, and that's one of those things where I think that's something I always like to point out to operations folks, that this is a way to make sure that, okay, I know what I've got for manganese interference on the front end. It carries over to the back end. And that's my way of saying, hey, I don't really have 0.04 chlorine. I've got 0.02 because I have a 0.02 manganese interference. So that's something that needs to be brought up as far as methodologies and everything else for your regulators. Happy to share that information with them if you want me to.
And obviously nitrites, the other way, if you were producing for some reason, you had a lot of nitrites, then you may be thinking you're okay on your residual, but you're actually over.
Yes. And nitrites will interfere negatively.
Okay. Other questions? And once again, we know we're talking about process here and these kind of items, but once again, both these gentlemen have worked on developing these sensors and selling them. So also questions about, any questions on the specifications or your individual needs that may, I'm sure they'll be only too happy to sell you any of these instruments.
We'll let Donnie do that.
Yeah. So Harry, I had another question for you. Now we do not have DO limits on our effluent, but we do have it's a report only type thing. And I suspect that some sort of DO limit may be at some point in the future, but we have a huge interest in ambient DO conditions. So obviously part of what's driving that is the DO coming out of the plant. So could you talk a little bit about the chlorination process and its interaction with dissolved oxygen? I have to admit, this is not something that I had thought about at all.
Well, chlorine is an oxidizer just like DO. So it really has very little effect on the DO levels that you're going to see. The sulfur dioxide or whatever you're using to dechlor is a reducing agent, and it will reduce the oxygen level significantly and cause issues if you're not careful. You can go anoxic if you're not careful, if you overfeed. Mm-hmm. So zero DO into your receiving stream is not a good thing.
No, that is bad.
The other part of that is, you said there are measurement only limit right now. You're measuring it and reporting, but there's no limit. The limit's coming if they're having you do that. Test on a regular basis. The limit will be next.
Yeah.
Next permit revision, you'll get a limit.
Well, it's been monitored for a while, but yes, clearly when being asked to monitor something, it's usually you can see where that goes.
Well, I've never seen them have you just monitor something and never put it in as part of your permit before.
Yeah.
You care to add something, Steve?
No, Terry, you got it covered there.
This is Adam at the Water Rec. So again, thank you for setting this whole thing up too, and Terry and Steve, thank you for your input too with respect to instrumentation. Kind of just more of a general outlook on things and just a question for the vendors. In general, we do all this because the ultimate goal is fecal. The fecal kill kind of tells us how we do. So we all know generally how much we're trying to dose our chlorine, and then obviously remove the chlorine prior to its discharge. Fecal though, for us is like, and I think it's probably same for everybody, we don't get those results to the next day. So some days, we don't even know if we have a problem until the following day. And a lot of these fecal limits that are in all of our state permits are sometimes there's daily maxes, there's geo means, but you really have this no more than 10% can be above 400. So chlorine obviously is our choice, or our disinfectant choice. And what we've been trying to investigate at the Water Rec here is there any reliable in-stream online fecal monitors? Now, we have one that we're testing out at our O'Brien plant. It's from Europe. But does HOC or Xylem or YSI know of any? Because really, that's the driving force. You only use these disinfectant chemicals to achieve your permit, and it's fecal. And monitoring techniques in lab, based on holding times and things like that, we don't know our results of the following day. So you don't even know that you have a problem, and you already might be 1 or 2 fecal counts already into it, and you could be pushing your 10% issue. So I just was curious. Again, I know this is not the topic. Do any of these vendors know
Related.
of any future inline fecal monitors? That's going to be like the driving force, of how much we dose and things like that we set. We know the generalities of what to dose and how much, but I just heard these manganate issues. Those could all be reasons that we go back and say, well, why do we have such a high fecal? Nothing's changed. The dose is the same. And all of a sudden there could be interference now that we can look for as operators. But just curious about fecal monitoring.
One way we can look at total bacteria count is with ATP. We do make an online ATP analyzer, but it's extremely expensive. The reagents are extremely expensive. I think we can look at some other things and maybe try and do a little better job on. One is that if I am adding chlorine to wastewater, and there's a significant amount of ammonia in that wastewater, we're going to make chloramines. Now, the chloramines tend to persist. So they tend to stick around longer and are more persistent. They're not as strong as the free chlorine. But your free ammonia level can have a big effect on whether I'm making monochloramine or if I have free chlorine available. So that can actually make a lot of difference in how good a kill I get.
Mhm.
So not only the manganese issue, but my ammonia affects whether I'm making chlorine or if I'm making, if I have hypochlorous acid, which is going to be the heavy duty killer. The other thing is pH. The higher the pH of my water, the less effective free chlorine is. Above 7.5, you start losing a huge amount of disinfectant value because your hypochlorous acid becomes hypochlorite ion. And hypochlorite ion is like 1/100th as effective as the hypochlorous acid. So it's a deal with swings in pH, large amounts of ammonia. All these things can really affect how good my chlorine dosing is. Does that make sense to you?
Yeah, yes, it does. Yeah, I see what what could impact the chlorine dosing. I was just curious if there's anything that's more real-time indicator of our overall kill, meaning, anything that's reliable in terms of bacterial counts out there in the industry.
Well, like I said,
we don't know that
ATP
the following day.
well, you can do an ATP test and have results in 15 minutes. And that gives a total bacteria count. And you can kind of correlate that and see how well that does. ATP can be used for a lot of other things in the wastewater plant, as far as determining the health of your aeration basins, all kinds of things. But it's a quick way, 15-minute test. I can see if I've got a huge amount of bacteria going out of my wastewater plant versus what I would expect.
What's a unit like that run?
$5,000.
And Terry, you were also saying that it's expensive to run in terms of the reagents, et cetera. Is what's sort of approximate? Once again, I realize that depends on sample frequency, but what would be your estimate of its annual running costs or monthly running?
Well, if you have the portable instrument, then you're looking at about $12 to $15 a test. If you're doing an online analyzer, you're talking about a $45,000 to $50,000 analyzer with reagent cost of probably $3,000 every 3 months. So it's extremely expensive. I'm interested to find out how that one works on that's supposed to give you an E. coli. That's something new.
Yeah, it's named as Proteus. It's a Proteus probe. However, we're having issues with it. So,
yeah, Adam, I saw that probe a couple of years ago when it was prototyped. It might have been at WEFTEC. And it was an interesting technology, but it seemed like it was based off of indicator organisms or kind of thing, and much the same way what Terry was talking about, any kind of life form is going to register on those things, which is and people will come up with it. So I think kind of I would take a wait and see approach on that. I'm glad you guys are trying it out. Curious to see how it works.
So are we.
In the meantime, though, in the meantime, I would say things like looking at the oxidation potential and looking at kind of ammonias and other things that can affect the pH, that could affect the contact time. At least the that formula is highly dependent on pH and the type of species that are in there, which is why some people have in the past used ORP probes in conjunction with online chlorine to kind of look at that potential and look at kind of what does that potential mean in terms of chlorine concentration, and and kind of setting it up so that the algorithm is based off of chlorine and ORP to get that whole contact time sufficient to give you a good fecal kill.
Thank you.
Okay, any other questions for our vendors? Or in fact, I'd say any questions for anybody who's talked today, or feel also free to introduce general questions about this whole process. Okay, if I'm hearing none, oh, sorry. I hear a
Steven, I
question.
just have one thing, sorry.
Yeah.
If any of you guys are watching with additional representatives from your lab and you would like to get them on the registration list so that they get the number for the
Yes.
wastewater and drinking water CEUs, just shoot me an email and I'll get them added once we get that number to get out to you. I've already had a couple people mention it in the chat, in like a personal chat to me, but most of you guys have my email, and so you can just get it back to me and I'll add you to that list.
Yeah, and if you don't have Dina, shoot it to me and I'll forward it on to her, but want to make sure that's their recognition that they were here.
Yeah, and I'll just throw my email in the chat. So
So Terry, we'll share your contact information, obviously, with everybody who was registered today.
Thank you very much. It was a pleasure. Actually, it's fun to talk these things.
Yeah, well, thanks. You got both of you brought a lot of information tonight, and I certainly learned a lot. Also, to John, Lucille, and to Rhys, thank you very much for sharing your expertise and your time with us today.
Thank you for having us.
So that we are, unless there's any other questions, I think at this point, I realize there's always a bit of a lag me asking, but we are going to be wrapping up the workshop. Thank you very much for attending. I hope it helped answer some of your questions and give you some direction on how you may proceed with dealing with this part of our new permits. I had sent an email out yesterday to people on our contact list that we have fallen into agreement with Illinois EPA for the, there was a final piece of the permit where there was language that we were uncomfortable with. And I'd like to thank IEPA for working with us and with US EPA to get that language removed from the permit. I think it's a much cleaner permit that meets everybody's objective with the language out. So those permits will be issued to the plants pretty quickly at this point, and we want to get that all wrapped up. I'll be sending out language for comparison purposes, but if there is anything in the permit that it causes you pause, please give me a call and I will check it against our master list. I think at this point, all the fecal coliform, waste load allocation and stuff has been dealt with. So it really boils down to this item about the dealing with phosphorus and the nutrient implementation plan, etc. So with that, we will wrap up. Thanks again to all the speakers. Thanks again to all attendees, and thanks to Dina for running the meeting. And have a great weekend.
Thank you. You too, Stephen. Thank you.
Thank you.